our graphic organizers for section 4.2. And we're going to talk about congruent triangles. So just one more time, we said yesterday for polygons, in order to show that polygons were congruent, we had to show that all the sides, that the sides matched up, corresponding sides matched up, and corresponding angles matched up, that they were congruent. For triangles, we have some shortcuts. So that makes triangles a little nicer to work with because we don't have to show all the sides and all the angles corresponding that are congruent. So we're going to start on the upper left side, upper left bubble of your graphic organizer. And we're going to start with the bubble that says SSS. These are all postulates. Postulates that we can use to show that triangles are congruent. Sides, we call this SSS postulate. Not postulate. And SSS stands for side, side, side. And what this postulate tells us in that first bubble there is that we have two triangles. And the side, side, side postulate says if all three sides are congruent, then the triangles are congruent. And I'll use some shorthand. And we should say if all three corresponding sides because we're not saying that all three sides are exactly the same, but our three corresponding sides are congruent, then the triangles are congruent.
So this is what we've been doing.
What's that?
This is what we've been doing. Right?
Well, it's part of what we've been doing because with polygons we said we had to show that the sides and the angles were congruent. But for triangles, if all the sides are congruent, that guarantees us that the angles have to be congruent. We can't make a triangle with those three sides that has different angles. So this is like a shortcut. If we know the three sides of the triangle are congruent, then we know that the triangles are congruent. And on your little picture, you have a picture there on your graphic organizer. So we'll just label your triangles. I try to draw these so they look kind of the same. And remember that in this chapter especially, it's important to go by what the diagram tells us, not by what it looks like. So for this, I'm going to say that's congruent to that. That's congruent to that. So if our triangles have three sides, three corresponding sides congruent, that guarantees that the angles have to be congruent. So the triangles are congruent. There's no other way we can put these three sides together that would have different angles. So this is one of our shortcuts for triangles. And when we work on problems with this, basically all we have to say for a reason that our triangles are congruent is if we have something like this, and we would say SSS. You know that means side, side, side. Questions on that one? All right, the next one down is the SAS postulate. SAS stands for side, angle, side. And what this tells us is we have two triangles. And if two sides and the angle between them are congruent, then the triangles are congruent. And it's important that the angle be between the two sides. We call that angle that's between the two sides the included angle. So in this case, included just means between. And for our picture, our triangles in your little bubble, look like this. So for side angle side, we would have a side here, an angle here. Sorry, that was I did the wrong postulate there. We would have our diagram would look like this. We have a side, an angle between the two sides. So this would be a side angle side. And we call this angle that's between these two sides the included angle. So the angle can't just be anywhere on the triangle. It has to be between those two sides. And the order that we use it in the name of the postulate is the order that they have to go in on the triangle. Side and angle on the side. And what this is telling us is if these things on two triangles are congruent, that guarantees that the rest of the parts are the same. The rest of the parts match up. You can't make a triangle any other way that would have these two sides in this angle and not match up on all the rest of the parts. So this is our second shortcut for triangles. Questions on that one? And again, all we have to say for a reason is SAS. Okay, our third one, up on the top right, ASA. This is angle side angle. And what this tells us, it's almost the same as the last one, that we have two triangles. And we have if two angles and the side between them are congruent, then the triangles are congruent. And we call the side, in this case, for this postulate, the side is the included side. So included, we're just using included like we normally use the word between. So our picture on in our bubble there, for our triangles, to mark those, we have our two triangles. And for angle side angle, I would have my triangle look like this. No, I did side angle side again. Sorry. So we have two angles like so. My angles would be here. There we go. There would be angle side angle. So we have two angles and the side between them. The side has to be between the two angles. We can't just have the side anywhere. It has to be between the two angles. And if our triangles, if these parts of the triangles match up, if these correspond and they're congruent, then the rest of the parts have to be congruent as well. So this is our third shortcut for triangles. And again, it's important that the side be between the angles. You have to go in the order that we say it in the theorem, angle, side, angle. Questions on that one? All right, there's one that I want you to add, not a bubble for, but just a little note on your graphic organizer. Angle, angle, angle does not work. And the reason it doesn't work, just a quick picture. So here are two triangles with the same angles that are not congruent. So this is why angle, angle, angle doesn't work. I can make the sides different lengths and the triangles still have the same angles. So this work, angle, angle, angle doesn't work for triangles. It doesn't work for any polygon. So I can have squares that are different sizes that wouldn't be congruent because their sides are different lengths. I could have pentagons, I could have octagons that have the same angles but different side lengths. They wouldn't be congruent. Now something special does happen when we have the same angles but different side lengths. We'll talk about that next semester. So some special things happen in this case, but it doesn't show that triangles are congruent. So angle, angle, angle never works to show that they're congruent. Questions? The other two we'll fill in later in the chapter for AAS, angle, angle, side, and HL. Those are some special cases. But those three are all that we're going to do today. On the back, I'm just going to draw some. I'll draw some triangles. I just want to figure out. We'll give the reason why they're congruent. So you may want to put them on. Maybe the last example is probably the most important one. These are all pretty easy examples. So I'm just going to draw some pictures, and we want to decide why these triangles are congruent. So why would these two triangles be congruent? Side, angle, side. And that's all we have to say. So my question up here is, why are they congruent? All right, the next one. How about these? Side, 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 and that's all we have to say. How about these? What's that? These are not. Right. They have to be congruent. They have to have the same angles and the same size. So these are not congruent. AAA doesn't work. All right, one more. Actually, I have a couple more. So here are my triangles here. How about these? Angle, side angle. Now in your homework and when you do other problems, these are very easy examples. But this is the kind of thing that we need to recognize: what parts are congruent, how they match up. Do they match up with one of our theorems, one of our postulates? Sometimes in your homework you might have to figure something out about the triangle in order to use one of the postulates. You might need to figure out an angle. You might have to use triangle sum to figure out a third angle. You might have to use linear pair to figure out one of the angles in the triangle. So you might have to do some other work before you can figure out the postulate. So let's do one more example that's just a little trickier, but I think we can get it. We want to know why these two triangles are congruent. Well, we haven't talked about HL yet, so we're not sure about that one. Tanner says side, side, side. Why side, side, side? There's only sides. We don't know anything else about the angle. So what do we know about this side for the two triangles? It's the same. It's the same length on each triangle. Segments are congruent to themselves. So I could write this in. That's congruent to itself. So this would be side, side, side. Does anybody remember what the property was that said that things are congruent to themselves? Remember that property name? Later in the chapter we're going to be doing proofs with triangles, and this property comes up fairly often. When something's congruent to itself, it's the reflexive property. And that comes up when we have triangles like this, when they share a part. So the reflexive property will tell us that this side is congruent to itself. Questions on these examples? Okay. Let me pass your folders back, and we will go over homework, and then I'll put today's